Okay, so I changed the view settings in the room settings, and I'll show you what I did very quickly. I do that so that you can see better what I'm talking about. So I close all this, I double clicked on room, I went to the room settings at the bottom, properties, then I went to viewport and cameras. Well, first of all, I set the room size to 400 by 400. You don't have to do that, but if you want to follow along, this is a way you can do it. Then clicked enable viewports, clicked on viewport 0, click on visible. Then I set the width of the first category to 400 and the height to 400. Then for the viewport, that was a camera property. For the viewport, I set it to 800 by 800. So this is all I did. It's just so I can show you what I'm doing a little bit better. So that when I click play, that the screen is bigger. And yeah, the last video was cut short because something came up. But we have a working collision code. Oh, by the way, I set the frame rate of the game to 30 just because when I'm recording, my computer struggles a little bit. But technically, we set it to 60. It's going to look smoother, and I'll show you how to do that as well very quickly. Options, main, general. Here I have it set to 30. Normally you'd want it to 60, unless for some reason your game doesn't need to be smooth. But if, in case of doubt, set it to 60. Otherwise, players are going to complain. I'm setting it to 30 because it's just a tutorial, so it doesn't matter. Okay, so back to the sprites and collision things. What I was about to say, by the way, F12 removes stuff. What I was going to say is that it's a good idea to make the hitbox smaller than the sprite so that the pixels on the very side, don't collide with walls. That makes it a bit more player friendly when he's moving around. So to do that, click on collision mask. If it's at automatic, it will be full. Select manual, and then whatever number you remove from one side, so I remove 2, you have to remove from all sides. So this one is at 15. This means I remove 2. It's not going to be 13. And that's the result. You can modify it this way as well. And yeah, that's going to allow the player to have a little bit more freedom when trying to go around the wall. And yeah, so that's the result of the collision so far, and we're going to modify it. I'm going to teach you a little bit more about collisions. So as you can see, the player goes a bit through the wall, but it's not that obvious. I don't think it's a big deal. If you want the player to show above the wall, if you click on the side, go in the room and instances, what you can do is this. You can add another instance layer. Click on instances, the normal one. Click on your player, press delete, or alternatively right click delete. I didn't explain how the rooms work. Sorry about that. I'm focused on the programming. Uh, put the player on the new layer, which is above, and I suggest you change the name. So you can press F2 or you can double click. Here we go. So this way, when we start, and we're going to check something. Does the game even show? Yeah, it does. Okay, I wasn't sure. Yeah. So now the player is going to show above the. Oh, I just realized a little glitch I had earlier, where the top of the square wouldn't hug the wall properly. It's actually just the color, the black color I put. So that was the reason. I'll change that so that it's. I'll change the background color actually. Uh, as you can see, I get lost in the detail as well. Okay, background. That's here. Background here. Change the color. Set to. That's a very ugly color. That should be okay. Oh no, that's not okay at all. Not very good either. I need to change the color of my walls. Sorry about that. It's taking a bit longer to set up. I'll leave the walls black. It'll be easier. Sorry about that. I see a bit of time here. Okay, that should be easier to see what I'm doing. Yeah, it's ugly, but we can see it, so it's cool. So back to the coding code. Actually, it works pretty well. So the only thing I would change is instead of affecting x directly, I would change the velocity instead. So what does that mean? What this means is, um, okay, I'll show you what I mean. Right now the player has instant acceleration. What this means is it always moves at its maximum speed, and maybe that's not what we want. Maybe we want acceleration. So we're going to have an acceleration variable, which might be uh, 1 or maybe 0.5, let's say. And now we'll have an acceleration script or an add velocity script. And here's how we're going to do it. SUR add velocity, and we're going to go with acceleration and the direction. So remember the input stuff that we did with the player? Calculate the input here. That gives us a direction, and with the max speed, we move from that. It's gonna be pretty similar. So oh, by the way, convention thing. The reason I put this in front of a word is because you can't mix it up with a global, not a global, but a built-in variable, and you can't mix it up with something else that you're using. So I have max speed. I'm not going to confuse it with it because this is basically a naming convention. The only variables with this in front of them are going to be temporary variables. So this avoids problem in the long run if I make a mistake somewhere or typo or something. So this is what this is for. So now what do? You add to x velocity. using the same function as before. And the same for the y-axis. I'm using these two ways of adding just so that it gets in your head that it means the same thing. So xl equals xl plus some function is the same as xl plus equals function. So that's why I'm using the two methods here, the two ways of doing it. Here it says I have a problem. Yval unique reference one. Yeah, okay. We need to declare xval and yval. And what do they mean? They're means x velocity and y velocity. Some people use h speed, which I think is very hard to read, and so you often write it wrong, and you won't know why your code is working. But x val, that's very easy to know if you spelled it wrong. If you write this, you'll know that this is wrong. If you write this, you'll know that it's wrong. So it's very easy to see on the eyes if you spelled it properly. So that's why I use those. So okay, so why do we need this? We'll go to the player. We'll put all the stuff in the right place now because it's important. So trying to zoom in so that you can see even if you're not in full screen. So that's acceleration. Those are the keys for the player. I selected all. Control X. I go to create event and I put it here. So because this is what we should have done in the first place, but it was a tutorial, so I didn't. But this is how things should be placed. It gets declared only once, so it's some optimization. Okay, so now that this is done, we need to add xval and yval. Technically, you could use the built-in hspeed and vspeed variables, which means horizontal speed or horizontal velocity and vertical velocity, which is basically the same thing, but it's built-in and it works a bit differently because of that. And you don't always know exactly what's happening with built-in variables, so I avoid them. You could call it xspeed instead of xval if you wanted to. Okay, back to the add velocity script. So I called it Excel, but this should be called amount because maybe it's not the acceleration. It can be, but not necessarily. It's always good to name your things as best as you can to increase readability. Okay, I'm not an expert by the way, but it's a good mentality. Now that's where the maximum speed will become important. So you're gonna check what the current speed is. And if you remember from the first tutorial, using point direction to know uh, the input, what was pointing towards, it's kind of similar to this. There's a function that is called point distance, which is to know the distance between 2 points. Quite simple. So if you put 0, 0, xval, yval, that's going to be the current speed of the player. That's the total velocity in one number. So what can you do with this? Well, we have a max speed, right? What we want to do is make sure that we're not going faster than our maximum speed. Otherwise, you're going too fast. So, and that's just what you want. So here's what you do. If current velocity is smaller than max speed, it will make sense to call it max velocity instead of max speed. If current velocity is smaller than max speed, current, yeah, okay, you need the current direction we're moving in. So it's not the same as the direction that you're passed in because that's for acceleration. But maybe the velocity that you just added, the way you're accelerating towards, it might not be the same as your current direction. Maybe you're moving left, and right now this direction is to move right, and well, that's a bad example, but it's not the same direction. That's what's important. You need to calculate it because it changes. So this gives you the current direction you're moving in. So now we can do max speed here. Well, equals going there, max speed there. So a better name for this would be direction we are moving towards. Don't be afraid of using long names if it makes it more obvious what it's doing. Ideally, without using comments, you should be able to look at the code and know exactly what it's doing. If you're able to, without comments, understand what it's doing, and somebody else would understand what it's doing, then that means your variable names are very descriptive and it makes it very easy to read. So that's the idea. If you need to make the name longer, go ahead. Direction we are moving towards. We are currently moving towards will be even better. So that's going to make it easier for you if you go back to work on the game 3 months later. It's going to make it much easier for you to understand what you did before and to continue working on your project. Okay, so the only disadvantage is if you zoom in too much, the words, well, you can't see everything. So I guess there are disadvantages to long names. So yeah, that's going to be uh, the new speed. Or if you were already at maximum speed, all it did is change the angle you're moving towards a little bit. That's what it did. But now you haven't moved yet. All you did is set up your velocity, your speed, and which direction you're moving towards. So you still need to move. You haven't moved yet. The only thing changes your velocity. So on your player. Okay, so here, instead of doing OX like this is the input. Basically here you want to accelerate. So you can replace this by our new script. Simply doing add velocity towards the input direction and with the right acceleration that you want. Now this is going to work well, but there's going to be one problem, and I'll show you. And afterwards I need to fix the movement script as well. Instead of adding one sec. Okay, there's a few ways we can approach this. We can pass in the xval and yval variables because now we're using those, right? So it will work. There's going to be one bug. I'm going to keep moving forward forever, but otherwise it's going to work. At least it should. That's a big mistake. No, it's not moving for it. Yeah, it is. It's good. There's a mistake somewhere for sure. So I'm gonna need check X input and Y input are 0. When you check for that and you add velocity, so what happens when we add velocity? And I mix something. Aha! I made a mistake. If the current velocity is bigger than max speed, then you need to change the current velocity. So this was a bug. Could have been this. And you don't have to do this, but one way to avoid bugs like that, and I don't always do it, is to always put the smaller value on the left. So this way, you don't have to ask yourself, okay, did I put the sign in the right direction? Did I put smaller than or bigger than? You don't need to ask this question if you're always using smaller than. But it depends on your keyboard. My keyboard, I need to press two buttons to put this instead of this, so just a thought. Okay, so if our current velocity is bigger than our maximum speed, then we're gonna change our current speed so that we don't go past our max velocity. That's basically what this is doing. So let's try this again. Okay, we have a bug here. I think I know what the bug is. Try to guess what the bug is. I'll show you the code. So, okay, when I move, clearly my velocity is fast because, right, I stop moving, and if I press on the opposite direction, it takes a few seconds before I change direction. So the acceleration is working. I can't change direction instantly, but if I stop pressing the button, the player stops. Try to figure out what the bug is. I'll give you a show the code and give you a few seconds. Okay, so if you still haven't figured out in World 2, just pause. Okay, so here's the bug. If the input, if the player basically tries to move somewhere, that's player input, then this code is read. You check the direction you're trying to move into, you add velocity, and then you move. If the player puts no input, all of this is skipped. So it's as if this whole thing here didn't exist. If the player isn't pressing any arrow keys or WASD. So, but the moving script is here. So that means the player won't move, also that it still has velocity. So all you need to do is move this right here. And since we have the other script, we can also replace this. Well, I'll just show you that it's working first. Okay, so there's acceleration, as you can see, and it kind of seems like I'm, as if I was ice skating. And the reason for that is there's no deceleration. And when I hit a wall, I keep my speed. So if I go down, whoop, now I fly past it. So there's no deceleration. So we need to change that in our collision code. There's a few ways to handle it. One way would be to return whether or not you hit a wall. So you could say, you could do it this way, for example, wall uh, collision detected, for example, false. Uh, how would you check? Okay, that's actually a good question. While there's no collision, run this code. Um, that's an interesting problem to solve. Uh, Maybe that isn't the best way to go about it. It's pretty simple, actually. Uh, Wait. Okay, I was gonna do this on my own, and then tell you the solution, but I'd rather show you my thought. So okay, so here's a few possible solutions. And if you don't fully understand what I'm saying, it's fine. Again, it's just to get you the gist of thinking as a programmer, I guess. So one solution could have been to set collision detected to false, and then um, set it to true in here, but it can't work because you don't check for collision. Well, I guess there's one way to go about it. There's one way that might work, which would be to only have distance traveled smaller than distance to travel in the while loop, and using place meeting as a different thing. So I'll show you how we could do that. So I'll need this to be in full screen. Okay, so instead of place meeting to be here, I'll try it, and if it doesn't work, it doesn't work. But I think it will. Okay, so as long as the distance traveled is smaller than the maximum distance you can travel, which would now be x velocity, right? It will be x velocity. So as long as the distance traveled is smaller than our absolute x velocity. If not place meeting, solid where we're trying to go, do all this, right? That was basically the same code. It's the same thing. And we can test it. We can test to make sure it behaves the same way, to know that it's actually the same code. So I removed one condition from the while loop, and I put it inside the while loop instead. And but it should be equivalent. If this is false, this doesn't run. Same as if it was in the while loop. Actually, there seems to be a difference because I'm getting stuck. So, oh, I know why. I know what the difference is. I need to quit the loop if there is a collision. And that will be break. So, if you remember when I told you what exit was to quit the whole script. So, it basically said, okay, stop right here. All the other things are irrelevant. Just stop right there. No need to read any further. Break is similar to this, but it works only in loops. So it works for while loops. It also works for loops, which I'll teach you about later. Um, I'll just show you what it looks like. But, so this is a for loop, and I'll explain to you what it does later. For now, while loops, you can use while loops instead of for loops. It's going to work fine. So if you're beginning, it's simpler to wrap your hand around while loops. Okay, so now it should work. Now it should be equivalent. If it isn't, then I'm very confused. But I think it's equivalent. It's equivalent. I don't get stuck on the wall. I get the same bugs as earlier, but nothing else has changed. So it's equivalent. It's the same thing. Okay, so now that we know that, if there's no collision, move as usual. Else, xl equals 0. That's it. That's the one difference. We're going to need to do this for the y-axis as well. But otherwise, it's the same thing. Um, no, it's not the same thing, but it's going to make it so that when you hit a wall, you stop moving forward. So if I hit a wall and I go up, I don't go past the wall anymore. Even if I go super fast to the wall, if I go up, I don't get past it. So it still does when going this way. And apparently it doesn't. Yeah, it does. Okay. So yeah, that's one solution. It actually works well enough that I might leave it like that because yeah, it works. So when you have a working solution, generally speaking, don't try to change it unless you really know that it's going to optimize it. It's going to be better. If you have something that's working, don't change it. Change it if you have bugs that you can't figure out how to fix. Then it's a good idea to start over. So okay, so now we have a loop. Um, I could make it more readable. So here's what I'm going to do. I'm going to remove the exclamation point, the not, and I'm going to put this on top. So it's easier to read. If there is a collision, set velocity to 0 and quit the script. Otherwise, keep getting closer to the wall. So yeah, that's basically what this code does. So I'm gonna go do the same thing with the other script. Again, it'd be very tempting to copy and paste, but I won't. Okay, because again, it's easy to have bugs that you don't notice if you copy and paste. So again, we'll remove the place meeting. It's going to become part of the inside of the loop. I didn't even explain if statements in the first video, so I said I was going to teach the basics, but I didn't. But I think, actually maybe I did. Let me know if there's something I need to clarify because maybe I skipped unimportant things. Oops, wrong conditions. Okay. If there is a collision, set the velocity to 0 because you hit a wall, so you shouldn't move towards the wall anymore. You should stop moving. You're on a wall. And then quit the event because we're done. We can't move closer to the wall. The script has done its job. We moved as close as possible to the wall as we could. And now we should have pretty well working script. Yep, doesn't seem to bug anymore. Okay, now we need a way to um, to decelerate. Yeah, because right now we don't stop moving. And I'll show you the easiest possible way first. And also, I'll change acceleration to 1 because it's very floaty and doesn't feel as good. So let's try with acceleration of 1. What does that feel like? It's better. Now we'll need some friction. So, and I'll replace this with the script we made earlier because it's equivalent. That's the idea behind using one script that uses two other scripts. If the modifications you made are in the new script are in the other script as well. So, and generally speaking, it's hard with GameMaker because a script. If you have too many scripts, it's hard to look around and organize yourself. But normally, you don't want scripts to do only the smallest possible thing, and then another script on top of it will use that one. So this way, if you have a bug somewhere, it's easier to track and find out where it is. Anyway, after you've moved, you're gonna want to apply some friction. And an easy way to do this is simply, well, that's the easiest way. Now again, xl equals xl times 0.9 is the same as yval times equal 0.9, except that this isn't the same variable, obviously, but otherwise they're equivalent. So, okay, if we do this, the player will slow down. But I have a bug. But he's gonna slow down all the time, and that's not necessarily what we want. He's behaving weirdly. Oh, let me check something. Seems like I have a bug somewhere. I'm not sure. Okay, so this should only happen when there's no input. And the reason for that is you don't want your player to slow down. Um, Basically, this is just for the game to be a bit smoother, to feel better. So when you start moving, you don't instantly go at your maximum speed. You accelerate a bit before, and then when you try to slow down, when you try to stop moving, you don't instantly stop moving. You slowly slow down. So this is what this is for. And another thing you can do is use this all the time instead of only when there's no input. You can actually do that. It's not necessarily a bad thing. Mm, Something weird is going on. I think there's a bug with my movement script, and I think it's that if the velocity is 0.1, aha, I know what the problem is. Maybe I started. with something a bit too strong. I probably should have just given you a working collision script because it's more complex than it seems. Um, yeah, but the fix is pretty easy. Before doing this whole thing, check first if there's going to be a collision at all, because if there isn't, why use a while loop and so many place meeting calls? You can just check once, and if there's a problem, then you do this whole collision thing. So if um, if place meeting x plus distance to travel, which is xval, y, I'm just solid. So that's one way to put it. It gets a bit harder to read, but only if you detect a wall, then you smooth collisions. I tend to put this higher up and having an exit clause again, and that's what I'm gonna do. Yeah, because I like it better. So if there's no collisions at all, ignore everything. And then this one I'm gonna copy it. So basically what this does is it checks first if there's gonna be a problem. And if there's gonna be a problem, there's a wall there, then and only then it's gonna do this whole thing here to approach the wall as much as possible and basically hug the wall. And the reason why there was a problem with it is even if the velocity is 0.1 or 0.2, the sign considers that it's higher than 0, so it increases the position by 1, which is bigger than 0.2. And so I'm not sure if you're getting what I'm saying, but in other words, the sign was bigger than the velocity. The sign of the velocity is either 1 or minus 1. The velocity can be smaller than that. So if there's no collision, then just quit. And yeah, yeah. So that's all we need to do. And I'm gonna go do this with the y as well. So here there's only one variable to change. Instead of x plus distance to travel, it's y plus distance to travel. So it's not a big change. So now we shouldn't get the bug anymore. Wait, yeah, we're gonna get another bug instead. If there's no collision, just move. So we need to have it here. Then on X, it's not perfect, but I still think it's a great learning experience. But I don't know, maybe it's too advanced. Sorry about that if it's too complicated. Um, maybe it's too complicated. Collision is a tough subject, so. But making your own collision script is definitely a great way to learn a lot because it's complicated and you're gonna make a lot of mistakes and you're gonna learn about collisions and you're gonna learn about while loops and for loops if you use those. You're gonna learn and sign and bugs that can happen if you make one little mistake. You can learn a lot from writing a collision script. It's not as simple as it looks. But it's not as complicated as it looks either, but you have to understand what you're doing. And unless somebody shows you, you're going to make a bunch of mistakes. mistakes that aren't obvious. Now the code should be working. Now we should be able to have good conditions working. Malformed, malformed assignment. Oh, y plus equals distance traveled. Otherwise, y plus distance traveled, that doesn't do anything. Now it should be working. Seems to be working. I'm not satisfied with the way friction works. The movement doesn't seem super smooth, and maybe that has to do with friction. Let's try this. This is basically friction. This seems pretty smooth. Again, if you don't want to use acceleration like that, maybe you're making a 2D Zelda game and you want instant movement, no acceleration. One thing you can do is, well, you could put acceleration to the maximum. You have a max speed anyway, so it's not gonna have, it's not gonna break. That's because of the max speed in it. But as you see, when you turn around, you turn instantly, so there's no smooth circle anymore. If you try to turn left or right, it's instant. You immediately change directions. But maybe a value of 2 would be better than what I have right now. Maybe it will feel more responsive. Because that's one thing. There's a little delay because you have to accelerate. So it feels a bit sluggish. I'm not exactly sure why. There's a time thing where you need to play with the variables a bit and see why something works the way it does. Yeah, lower friction is better, I think. Okay, I'll show you how to change the angle depending on where you're moving towards. So I'll try to make an arrow shape so that's more obvious. That's a beautiful arrow. I say that sarcastically. First, I'll make the player point towards the towards where it's moving. So if you remember, with point direction and the input, we could use we could just use that. And okay, I'll show you the first way that you think about doing it, and it will be with image angle. But there's a problem with this variable, and the problem is it changes the hitbox. I'll show you what that means. Oops, there's one thing I did wrong. Um, okay, yeah, everything points towards the right in GameMaker in the normal angle. So now the arrow points towards the right spot. If I go left, there's no bug. If I go right, there's no bug. If I go down, there's no bug. If I go up, there's no bug. What happens if I go in the corner like that? Oh, I can't move up anymore. That's weird. Oh, I can't move down. What's happening? What's that? That's weird. Well, the reason is when you rotate the image like that with image angle, it changes the hitbox as well. So what you want to do instead is have a different variable. So it could be player facing, or it could be even just facing. Yeah, facing would be best. So here in the beginning, add facing, set it to 0 as a default value. And yeah, to explain a bit better what I did here is this is where we were using the input where the player wants to go. And basically all I did was set the image angle to the direction the player wants to go. So that's why the player is basically looking in the direction he wants to go towards. Another thing you could do is set it towards the direction of where you're moving, because it's not exactly the same. If you have a low friction and you're basically sliding on the floor, you're not moving in the direction that you want to go in. You're moving in a different direction. So it depends what you want to do. You want the player's head to look at where it wants to go, or do you want the player's head to look towards where he's actually going, even if it's not there that he wants to go. It depends on your game. But for a shooter, you normally want to aim towards the enemy, towards the mouse. And if you're not aiming your gun, maybe you have no gun, maybe you have a mini weapon, then maybe you want to aim towards where you're going and not towards where you're aiming with the mouse. So it depends on your game. Uh, anyway, facing, then you're gonna need to change the draw event. So we're gonna add event, draw event. Now this is a bit annoying to do because there's so many variables. But you're gonna need draw sprite extended, and you're gonna do sprite index, which is the sprite of the object, and you're gonna do image index, which is the default image of the object. X, Y, image X scale, which is a default. That's basically the size of the object. There's a ton of variables. I'm sorry about that. I didn't decide this. Um, but they're all useful when you need them. Rotation. Okay, so it tells you at the bottom everything it needs. So sprite, sprite index, sub image, image index, XY, XY, X scale, image X scale, Y scale, image Y scale. Rot means rotation, and that's where you put facing, where you want to look towards. Color, you put it at C white, that's the default color, so use that. And image alpha, you can use image alpha. So yeah, it's a long text. One thing you can do if you want it to be easier to read is, and I do that a lot when I need to, you separate all the variables like this. It can make it easier to read what you're doing. Then like a script or function or a block of code, that's basically what you're doing. Well, I need to go for now, but you won't notice that.